Hey guys, my name is Saib and welcome to another episode of this Canvas game development series. This episode we're gonna follow up with PixiJS. We're gonna introduce some new concepts in PixiJS and know more about the Pixis API so that we can actually use it to build a game. Just a note before we actually go into our episode. I'm not gonna go over all of the Pixis API since it's a huge API. I'm just gonna go into the things that we actually need in order to build a game, but I'll be covering the most aspects of it so that you can actually go on and you'll understand everything after that. So yeah, hopefully. And okay, so in the previous episode we've set the Pixis coding environment. Now we have a canvas element of size 800 by 600, I think. Yeah, 800 by 600, and we knew the render view is exactly the same as the canvas tag element. Just as the plain canvas element, we can style it the same way. And we have the stage. Our stage is the root container, which contains all of the visible things that we're gonna see in our canvas. Now the stage here is just a convention. You can call it a scene, you can call it a root, but you should know that the render needs something to render, and this thing is called the stage. And this stage contains all of the visible things that we're gonna see in our canvas or in our game, all of the actors, all of the objects, everything, basically everything we're gonna see in our game. And Pixi requires you to have one container at least in every app or every game, for instance, since, as I said, the renderer will need something to render, which is the stage. Okay, now in the previous episode we've gone a bit into sprites and how we can draw them, and I'm here gonna follow up with details and everything that we need to know about sprites in Pixi. So if we want to draw sprites, we have two ways. Either we can use a single image file, such as the spaceship that we actually drew in the previous episode, which is that one, and we can use a tileset. A tileset is simply just one big image that has all of the sub-images or all of the graphics that we need in our game or an application. So if you're looking at this tileset, it's just an example, you can see that it has all of its pixel arted, I think. So yeah, it has all of the images that we need in our game, so we can build an entire game out of all of this tileset. So yeah, we're gonna use this one in order to actually show you an example of how to use any sub-image in here. So this is a sub-image, this is a sub-image, and all of these images are a size of 32 by 32. So yeah, I'm gonna show you exactly how we can make sprites out of a tileset, since I showed you how to make a one by using a single image in the previous episode. But today we're gonna go into much more detail so that we actually understand it more. Okay, so as I said, we have two ways, either from a single image file or from a tileset. Okay, the first thing we're gonna go now is something that's called a loader. And the previous episode we used a loader in order to load an image into something that we called a texture cache. Now Pixi has a system of storing and referencing all of the textures that we have into a texture cache. This texture cache is used to reference all of the textures that are the sprites will need, since we said that an image has to be converted into a texture, and that's all related to Pixi's way of doing things. Since Pixi uses the GPU in order to render images, not Pixi exactly, it's the WebGL. As we said, WebGL is just based on OpenGL embedded system specification, which interact with the GPU, the graphics card, to achieve a hardware accelerated graphics or high performance graphics. So yeah, a way that we can actually communicate with the graphics card is by using textures and not the ordinary images. So we have to convert an image into a texture, and then we can use the sprite class in order to actually render this texture that we have. Okay, let's start to do some coding. I hope that makes sense. And okay, so the first thing that we're gonna do is we'll try to make things using aliases, since it eases the writing the long code and long formats or methods of Pixi. So let's say that I want to call the texture cache in here, and I want to call it, for instance, I want to give it the actual Pixi utils, and it's called texture cache like this. So instead of actually using this, we can use this texture cache. And I didn't go through this in the previous episode. We used a loader, and okay, let's specify a loader first, the same as we did in the previous episode. It's pixi and it's a loader. Since this loader, as I said, anything that starts with a capital in here means it's a class. So we use this new in order to make an instantiation of this class, since this is actually a constructor of a class. Okay. Now, if you want to load any images or any images that we have, we can just use the loader. So I can just say loader, and I can use add, same as we did before. Now we have to pass a string, which simply stands for the location of this image. So it's in my assets folder, and I can use the TileSet.png that way. And then if this image is added, we can use load, and I'm gonna call draw, which is this function that I'll be defining now. Okay, so we added this image into the texture cache, that way using the loader object. And now if you want to refer to that image or that texture in the texture cache, we simply just, let's specify a variable for that, and I'm gonna say a texture. Of course, you're not gonna call it texture when you actually build a game or any app, but now I'm doing this to actually show you how we can come up with an image in our canvas at the end, of course, because we haven't finished that one at the end. So okay, now if I want to as I said, the texture cache is a way we use to store all of the references to a textures that we actually loaded with this loader. So I can just say in here, I can use the alias that I used, which is texture cache, instead of using the whole thing. So yeah, texture cache that way, and I have to use the square brackets, and I have to pass the same name, which specifies the location, as I said. Okay, so we loaded this TileSet into the texture cache, and now we can use the texture cache to reference all of the textures simply by passing in the name or the location, which is the location of that one. We can specify a name for it, so I can just say in here, I can just call it, okay, do that like that, and I can give it a name. For instance, it's called TileSet, and I can just use a TileSet as a name, TileSet like that. But let's keep it with the same way. It's just I just want to do that so you actually know you can do this. And okay, keep the location like this. Now if I want to draw a single image, all I have to do is I'm gonna say let's sprite, and I'm just gonna say new pixi, and I make sprite instantiation of this class, should be capital since this is a class and I'm making instantiation, and I'm gonna have to pass the texture in here. Instead of using the same as the previous episode, we used the loader and the resources, and at the end we convert it into a texture. We don't need that anymore since we actually referenced that texture from the texture cache. So yeah, all we have to do now is pass in the texture. Since this is actually a texture, it's been converted by the loader since it's been added to the texture cache like this. So as I said, Pixi eases everything. All we have to do is just follow these steps in order to make things show up in our canvas. So now since I'm actually using this TileSet, let's replace this with a spaceship, since this is a like this, and I'm just gonna go stage and add child, same as we did, and call it sprite, and I can render this that way. Now I should see the spaceship in here. Everything works fine. But in our TileSet, we don't want to render the whole image or the whole TileSet in here. We want to pick up some images, and that is easily done. Pixi has an easy way to do this. I know it's happened. Okay, and the way we do this is simply by replacing this texture. I'm gonna call it. Now what I'm gonna do in here is, which is the different from using a single image file. Now we use the TileSet. The way we do this is simply we specify a rectangle object. So I can just say rectangle. You can call it, give it any name, and this rectangle object will define the size and the position of our sub image in here. So if you looked at this subset, you can see that all of these sub images are of size 32 by 32. So if I want to access the second one, I can simply say this is 0 for the x-axis. So if I call this function now, I can just say new, say pixel called rectangle object like this. Now this rectangle object is the same as the rect method in Canvas, but this object is just a data object, which means that it's not gonna, if I try to draw this rectangle by using this rectangle, it won't show up. This is a data object that we use in order to specify the size and the position of our sub-image in this tile set. I hope that makes sense. So now we're gonna pass in the initial point from where we're gonna specify the width and height. So if I set 0, 0 for the x and y and specify the size, which is 32, 32, I'm gonna have, it's gonna go in here, which is 0, 0, and it's gonna cut 32 width and 32 height, and I'm gonna have my first image that way. But let's say that I want to use this box in here. If you try to actually go here, you can see that this is 0, this is 1, 2, 3, and 4. So I'm gonna multiply 32 by 4 to move into the y-axis, and the x is simply 0. We don't move in the horizontal one, we use only the vertical one. So if I multiply 32 by 4, I can start in here and I can cut the width and height, which is 32 by 32. I hope that makes sense. It's simple mathematics, or just you can sum it up if you don't want to multiply it by 4, but this is an easy way that you can use also in the horizontal one, not just the vertical one. So I'm gonna say in the y-axis in here, in the y-coordinates, multiplied by 4. Okay, now what we're gonna do is we're gonna give this texture the rectangle data object, which is specifies the size and the position. So what I'm gonna do is I'm gonna use the frame method like this, and I'm gonna equal that to the rectangle, so that now the texture has the size of this rectangle, which is this sub image that we're gonna use. Now we assign the sprite of this texture since we specified the frame for that, and if we looked at it, you can see refresh. Okay, something went wrong. You can check the canvas. We can see that the frame does not fit inside the base text dimensions. So if you try to check that one once more, you can see that this is the texture and the texture cache. Okay, we haven't changed the tileset. This is a dumb mistake. So now if you refresh everything, you can see this, that we have our box. We can scale that one to simply by changing, let's change the x and y for that. Let's make it 200, y 200. We've gone through the properties and the positioning and the rotation of sprites in the previous episode, so I'm just gonna skip the unnecessary details in here. So now let's specify scale, and we can set the two values like this, or we can simply just say x and y in another statement after that one, but you can use set. So if I want to double the size, I can just say 2, 2. If I want to halve the size, I can say 0.5. Triple the size, I can say 3. And yeah, same as the canvas one. Okay, now we have this image. Let's start to double that one like this, triple that one. Now if you looked at the sprite in here, I don't know if it's obvious, but you can see this glitch, graphic glitch in here, which is simply from the neighboring image. If you looked at the tile set in here, you can see that this box is actually, that line is from the neighboring image, since the GPU doesn't have a pixel perfect accuracy, which means that the GPU didn't exactly cut that image like in a perfect sense or a perfect way. So there's a way we can actually solve that. This graphic glitch, by the way, is called texture bleed, and as I said, it's from the neighboring images, which means that the GPU, when it tried to render the image, it didn't cut perfectly. So you can see this. You can see that this won't happen to the bottle in here, but since this one actually has like a background in here or simple lines, but we can save that with the scale mode, pixi scale mode method. But before that, if you want to know why, because the graphics card or the GPU uses and deals with floating points, not and integer values. So we can actually alter that by changing the algorithm that the GPU uses to extract pixels. So we can just change that into working with precise integer values. As an example, if a pixel position might have a precise integer value of 8, for instance, if you look at this, of 8, you're gonna see that the GPU uses a floating point representation of numbers, so it may have like 7.999 and it goes on. So we can change that by simply going to the nearest value, integer value, and actually cuts it. No need to go into the details. All you need to do now is use a simple method, which is, you can call it in here, I'm gonna refer to the texture, which is our texture, our TileSet, and we can say base texture, and we can go to the scale mode. And what we're gonna specify in here is we're gonna call pixi, and we're gonna say scale modes, and we're gonna pick nearest like this. Now if you actually save this one, you can see no more graphic glitches or no more texture bleed, and it's much more perfect. If you want the GPU to go back to using the floating points and to actually draw these images, all you have to do is simply, we can use the scale mode, and you can just say linear. Make sure it's capitalized, linear, like this. But let's keep it to the nearest so that we can actually have no more texture bleed, and we can have our sprites like this. So if I try to use different, let's try to 0, 1, 2, 3, 4. If I try to go to this weapon, you can see if you can try to count it, it's 1, 2, 3, 4, 5, 6, 7. So I'm gonna multiply this by 7, and I'm gonna see my sword in here like this. So yeah, and as I said, using a TileSet is much more memory efficient and faster performance. You don't have to include all of these separate images in like an assets folder like this. So you can just use a TileSet. And yeah, I hope this was an informative episode, and I'll see you in the next episode where we'll go over much more things in Pixi, and you can see the power of Pixi in the upcoming episodes, hopefully. So I'll see you in the next one.